So determinant, it is the continuation of matrix. What is a determinant? It's a number which you can assign it to a square matrix. So it is defined only for square matrix, and that is why it is written it's a unique number assigned to a square matrix. Means every square matrix can be assigned to a unique number, only one number, 2, 5, minus 3, like that, any number. That number is called a determinant. So it's a number, not a matrix. So every square matrix having a number, that number is called a determinant. Now, here how to denote a determinant? It is written determinant of A, means if A is a square matrix, then its determinant is denoted by, it is for observing modulus A, but it is reading as determinant A or DET of A. Determinant A or DET of A means dict of A, determinant. Now, for one order means if there is only one element. If a square matrix having only one element, one by one order, then that number itself is the answer. You see, minus 3 determinant is minus 3 itself. It is not modulus, so it is determined that number itself is the answer. So 5 itself is the answer. So for one order, that number itself is the value of the determinant. For two order means 2 by 2 matrix of order, determinant value is main diagonal product minus subdiagonal product. AD minus BC. A into D minus BC. Main diagonal minus subdiagonal. Here also 3 into 1, 3 minus 2 into 5, that is minus 10. So 13 is the result. So for two order, it is written product of main diagonal minus product of subdiagonal. Means main diagonal elements product minus subdiagonal element product. Now one example is that suppose I want to equate these two and get the value of x. I cannot correspondingly equate in a matrix. It is possible to correspondingly equate, but in a determinant you have to calculate what is the value. This value is x square minus 36 and this value is 36 minus 36. So x square minus 36 must be equal to 0. So you will get x is equal to plus or minus 6. If you are directly equating, you will get only 6. But it is wrong. The correct answer is x is equal to plus or minus 6. Now, what is a minor? Minor and other word is cofactor. There are two words we are going to study. Both of them are defined only for square matrix and only for square matrix defined. It denoted by Mij, means every element of a square matrix having a minor. It is denoted by Mij. How can we obtain? That is written there. I will help you with the help of, or I will explain with the help of example. This is a 3 by 3 order. So 5 having a minor, 4, 3, every element having a minor. So 5 is in the first row, first column. So it is denoted by M11, means minor of first row, first column. That is minor of 5. Now can you get it? This 5 containing a row and a column, 5 containing a row and a column. Remove that. The remaining 4 elements you form a determinant. And its value is minor. 1 into 0 minus 3. So that is 0 minus 3 is 3. Similarly, M12 minor of 1 to first row, second column, that is 4. So 4 having a row and a column. The first row and the second column. Remove. Remaining elements are 2 minus 1, 4, 0. 2 minus 1, 4, 0. You calculate, the answer will come 4. Similarly, minor of first row, third column, this element. That is these 4 elements left, 2, 1, 4, 3. That is written. So you will get 2. Similarly, second row, first element is written here. Second row, first element. This you remove. You will get 4, 3, 3, 0. Like that, all values, and the rest I calculated here. M31, M32, etc. So all elements having a minor. So it is written there. It is a determinant obtained by deleting ith row and jth column. Means whatever the present row of that element and column, that row and column you remove, remaining you make a determinant. Now what is a cofactor? Cofactor is signed minor, means in the minor you have to put a plus or minus symbol. That is what is called signed minor. It is called cofactor. It is denoted by Aij. Any of the capital letter followed by Ij. Aij. Aij, how can you obtain this? Minus 1 raised to I plus j, means this I and j you add and put in the power of minus 1. You will get plus or minus symbol that you multiply with mij. Example, A11 means minus 1 raised to 1 plus 1, 2 into M11. Similarly, A12 is minus 1 raised to 3 into M13 and so on. Here, in the above example, A11 is 3 because 1 plus 1 is 2, minus 1 raised to 2 is a plus number, so it is 3 itself, whatever the minor is that itself. But A12 presently for sign will be changed because 1 plus 2 is 3, minus 1 raised to 3 is negative. Similarly, A13 whatever is written, A13 is 2, so same here, A13 is 2 only, whatever M13 because minus 1 raised to 1 plus 3 is 4, that itself is the answer. Similarly, all other elements you can calculate, change the sign, only keep it in mind. If the sum of the elements is even, then minor and cofactor are same. If sum of the position is odd, then whatever the minor is there, its negative will be the cofactor. That is written. This is 3 by 3 order sign of cofactor. It's plus minus plus. Plus is because of 1 plus 1 minus 1 raised to 2. It is even. So plus minus plus minus plus minus plus minus plus. Then value of order 3 of determinant is, you take any one of the row or a column and multiply it with the corresponding cofactors and add. So it is written there, sum of the product of a row or a column with its cofactors, you will get the value of order 3. Means take one row or a column and the corresponding cofactors you multiply and add. Here 5, 4, 3, first row I took 5 into its cofactor, that is 3, 5 into 3 plus 4 into minus 4 plus 3 into 2, 3 into minus 2. So 3 into 2 is there or minus 2 is there? 3 into 2 is there. So 3 into 2. So whatever is coming, that is the answer. So you will get 15 plus 6, 21 minus 5. That is 5 is the answer. So let us see what is coming back. So the order 3, sum of the product of a row. There are 3 rows and 3 columns, so total 6 ways you can find out the value of this determinant. You take any one of the row or a column, multiply it with the corresponding cofactor and take their sum. Here 2 examples I have shown. First is 5 into 3, 5 into its cofactor plus 4 into its cofactor plus 3 into its cofactor. Total simplify will get 5. With respect to last row also calculated, 4 into minus 7, 4 into minus 7 is written there, cofactor is written, 4 into minus 7, third row, first one. Then similarly second element 3 into 11 plus 0 into that number, so there also will get 5. All the 6 ways, 3 column and the 3 row ways, the result remains 6. One of the application of a determinant is to find the area of a triangle when its vertices are given. Suppose A, B, C are the vertices of triangle ABC, then its area is denoted by delta symbol, it's capital delta. It is modulus of, this small line is modulus of, because area cannot be negative, half of a determinant you have to make. You take any one of the row or a column as 1. I took a 1, 1, 1 in the first row. You may take in anywhere this 1, 1, 1 in a row or a column. But if you are taking 1, 1 in the first row, then correspondingly you write the other vertices. With respect to that 1, 1, 1, you write x coordinates and y coordinates. You may write 1, 1, 1 in the column, then with respect to column you write the x coordinate and y coordinate. Now, this an example, 3 vertices are given. So this time I took 1, 1, 1 in column ways. So the vertex x coordinates I took 3 minus 4 5, 3 minus 4 5 with respect to that. Then 8 2 1 with respect to that. Simplifying, we will get 61 by 2 square units. Also, if ABC are collinear, then this area is equal to 0. So collinear means they will lie in the same line. Then area becomes 0. Then this determined value becomes 0. Because half never will be 0. This determined value becomes 0. Here one question is there, if area is given with the vertices this, then find the value of k. It's an important question. So this area is given as 35 to 111 in row wise. So with respect to x coordinate and y coordinate I have written. Simplifying, determinant expanded with respect to that. It is 1 into 20 minus 4k minus 1. Minus 1 is because of its position. Minus 1 into this and this one 8 plus 6k and plus 1 into 8 plus 30. That is written. Simplifying, we get a modulus of this. Modulus is because of area. Area cannot be negative. So k will, there are two possibilities when you are removing modulus. K equal to minus 2 or 2 values are coming. Now singular matrix. It is defined only for square matrices. Most of these things are only defined for square matrices. So for any square matrix A is singular, if and only if this determined value is 0. The determined value is 0, then only it is singular. Singular matrix means its determined value is 0, otherwise it is non-singular. Then example. This is singular means its determined value is 0, simplifying 4k minus 10k minus 5 equal to 0. So k equal to minus 5 by 6. Now what is adjoint of a square matrix A? It is denoted by adj of A, where A is a square matrix. Adj of A is the transpose of the cofactor matrix. After making the cofactor matrix, you take it transpose. One example is written. It's adj. Adj means you have to write all the cofactors and take the transpose. The cofactor of these 3 is this row and this column is gone. 1 1 is the position, so it is positive. So this 1 remain. Determinant of that is 1 remain. This the cofactor of 5 is the second element, so it will come a minus. This and this is gone, remaining minus 2. Similarly, 2 also having a minus because position is 2 1. 2 plus 1 is 3. So it also will be a negative. And so that is written here, and I took the transpose. This is adjoint. Then inverse of a square matrix. Inverse of a matrix is defined as A inverse or denoted by A inverse of INV of A. It is same as adj upon determinant, where determinant cannot be 0, means A cannot be a singular matrix. If A is singular, then inverse is not defined. So it is inverse is defined only for non-singular matrices. Non-singular matrix only inverse is defined. So A inverse equal to adj upon determinant, where determinant cannot be equal to 0. So A inverse equal to here, this it's in A inverse is the determined value is 3 minus 10, that is minus 7. So you divide it by 7, minus 1 by 7 into that cofactor. This adjoint is determined. That is inverse. Now here one of the important thing is B is the inverse of A. If you want to say one is the inverse of other matrix, AB, yeah, BA, whatever you multiply, you must get identity matrix. Otherwise, one is not the inverse of it. AB equal to IA naught, BA is equal to IA naught, both must be equal. AB also must be I, BA also must be I. Then only we can say one matrix is the inverse of other. Then some important points are there. When you are multiplying a matrix with its inverse, always it will come I. A into A inverse is same as I. Yeah, A into A inverse into A is also I. Then determinant is another very important result. Determinant of adj is determinant A raised to n minus 1. A relation between adj and determinant. Determinant of adj is always determinant A raised to n minus 1, where n is the order of matrix A. Suppose A is having 3 order, then 3 minus 1 2 order, then 2 minus 1 and so on. It's a very important relation. Then this also another important relation. A and adj if you are multiplying. Yeah, adj and A if you are multiplying, always the result will be determinant A into I. These all results are very important for 1 mark question. Determinant A into I. I you know identity matrix. So A into adj, adj into A always is equal to determinant A into I. Okay, so let us see some other properties also. The results are very important for 1 mark questions. So here the next property is coming as the determinant of K, where K is a non-zero real number. Then This K, how many times will come outside? Whatever the order of A, that much times will come outside. Suppose A is of order 5, then K raised to 4 will come outside. If A is of order 3, where N is the order of matrix A, if A is of order 3, then 2 times K will come outside. Example is written. If determinant A is 4, determinant of 3A, where order of A is 3 is given. So 3 raised to 3 minus 1 to determinant A, that is 9 into 4, 36 is the answer. That type of question is very important. Similarly, determinant of A, B is equal to determinant A into determinant B, where A and B are of same order, then only. If A is a square matrix of order 3, such that one question is determinant A is minus 5, find the value of determinant of J and determinant of 2A. From the results we can write. Determinant of J, since A is of order 3, determinant A raised to 3 minus 1, result is written, that is 25, because determinant A is minus 5 raised to 2 is 25. Similarly, determinant of 2A is 2 square, because order 3, 2 times 2 will come outside into determinant A, that is 4 into minus 5, that is minus 20. Another application of determinant or matrix is solving a linear equation in 3 variables. So it will be given using matrices or using inverse, solve or find the value of x, y, z. Then here how to do, it's another important type of question, most probably a 5 mark coming in the examination, 5 mark question. Now here you will take x, y, z coefficients as a matrix. X, y, z coefficient as a matrix. 2, 1, 1, 2, 1, 1, 3 minus 1 minus 1, 3 minus 1 minus 1, 2, 2 minus 2, 2 minus 1. So all the x, y, z coefficients you take as a matrix A. Then you find out its adj, you know, write all the cofactors and these are the cofactors, take it transpose, you will get adj, transpose is written there. And the determinant A you divide it by adj, determinant A you know how to calculate, determinant A you divide it by adj, you will get A inverse. So A inverse equal to 1 by 15, because 15 is going to be the determinant value calculated, and you will get determinant A inverse equal to determinant A into adj. So adj divided by inverse equal to adj divided by determinant A, it is the result. So that is A inverse. Then take these variables as a matrix x, y, z, and constant in the right hand side another matrix B. Then this x will be always A inverse into B. This the values of x, y, z will be whatever A inverse you got, multiply to B. That means x is x, y, z is equal to A inverse is written, multiply with the B matrix, you will get 2, 0, 1. Out of this x is 2, y is 0 and z equal to 1. Just multiply and not shown the multiplication, you multiply and check it. It's very important one. Another question is that same question can be asked in alternate way. A matrix is given, you find out its inverse and use that inverse to solve this. So very carefully observe. These inverse you have to calculate without observing what is written here. So first I calculated the inverse. You know at j upon determinant. The inverse is calculated all the cofactors and all the methods I explained earlier. So at j upon determinant A inverse is calculated. Now you will observe these matrix coefficients are how it is related to the given equations. Here it is 1 to 0, but here the coefficients are 1 minus 2, 0. So that means these coefficients are not written here. Such cases you will see in this direction whether the coefficients are getting or not. 1 minus 2, 0. Yes, it is coming 1 minus 2, 0. Second one you see 2, 1, 3. 2, 1, 3. And the third one 0 minus 2, 1. 0 minus 2, 1. This time actually the coefficients are written in the column wise, not row wise. Previous case, the coefficients we took in a row wise, but this time the coefficients are given in a column wise. It is given, so we cannot change. So such cases, if we want to find out the solution by using this inverse, so first you will take its transpose, because these are not the coefficients, so you will take, you will make that coefficient. For that you have to take the transpose. So A inverse transpose. A inverse transpose is same as A transpose inverse. Means after finding the inverse you take the transpose, or after finding the transpose and you take the inverse, no problem, the result remains same. So A inverse transpose is same as A transpose inverse. So its inverse is written there, its inverse. That you multiply now with the constant matrix. Now that constants you multiply here, you will get this to multiply, you will get x as 4, y as minus 3, z as. It's a very important time. See the observation. Your equation is given 5, your matrix given and then solve. So such cases same is given. Means this itself is the coefficient, direct you multiply. If the coefficients are in transpose, first to find out the transpose of the inverse, then only you multiply. Let us see some other points. As I told you, A transpose inverse is same as A inverse transpose. That's always true for a square matrix. And if AB and BA both are a constant into Y, identity matrix, then you can find out A inverse or B inverse by, if you want A inverse, then A inverse is equal to 1 by K into other matrix. If you want B inverse, then that is 1 by K into A matrix. One inverse can be obtained by dividing the other matrix by the constant, where constant is not equal to 0. Here one example is there, or one of the important question is there. Here A and B are given two matrices. You have to find out the product and using that product to solve an equation. So first, when you are finding the product, you will always get an identity matrix into a constant. If this is 5, then everywhere 5. If it is 10, everywhere 10. Such a matrix you will get. If not getting such a matrix, then you cannot go ahead. So always you will get a constant into an identity matrix. Maybe asking you to find out BA, then also first you write B, then followed by A, then also you will get a constant into identity matrix. Then only such a question can be solved. This solution can be there. Now after finding AB, you will see that either A or B are the coefficients of x, y, z, either in row wise or column wise. Here these coefficients x, y, z are forming by A. Sometimes it may be with its transpose, just like the previous case. Then you have to do. You have to take the inverse transpose and then multiply. Here not a problem. Here directly given as that. So I find out A inverse because AB is equal to 6 as I told you. So constant. So A inverse is equal to 1 by 6 into B. B matrix is already here. B matrix is written here. So B matrix is written here, and the constant matrix written, the RHS is already taken there. Then A inverse you got. Here we will not use any cofactors. A inverse already we got. Now this A inverse you multiply with this constant matrix, you will get x, y, z, x 2, y minus 1, z 4. So this is the method. In case here transpose is required, then after taking the transpose only you multiply. Now some of the important notes: if the given equations are of the form Ax equal to B, where A is the coefficient matrix of A, coefficient of x, y, z, just like in the previous case, coefficient of x, y, z, x are x, y, z, and B is the right hand side constant matrix, then when can you say there is solution or not? If determinant A not equal to 0, this coefficient of x, y, z matrix is not equal to 0, then only unique solution and equations are consistent. Then, if determinant A equal to 0, there are two possibilities. Then you will see at J and B not equal to 0. At J and B not equal to 0, then no solution, equations are not consistent. And if determinant A equal to 0, at J and B equal to 0, then infinite solution, then equation may or may not be consistent. We cannot say it is always consistent, may or may not be consistent. These concepts you keep it to get the assertion reason question. Not that, no other uses are there. It is useful for assertion reason questions.